Here in this video, we are solving two problems in waves. The simplest problem first. Two vibrating tuning forks produces progressive waves and their displacements are given for you. What are the number of the beats generated per second is the question asked. So if you look at the equation, it is given that y1 equal to 4 sine 500 pi t. The general equation equal to y equal to a sine omega t. That is a sine omega means 2 pi n into t. So how much is there in the place of 2 pi n is, or 2 pi n1 being a first one, 2 pi n1 is 500 pi. Pi gets cancels. So n1 equal to 250 H. Similarly, for the second equation, 2 pi n2 is 506 pi. Pi again cancels. So n2 is 506 by 2, that equal to 253 H. As we know, number of the beats per second, be careful, number of the beats per second is the difference between the frequencies. Among them, the higher frequency is 253, lower is 250, as we have discussed. Beats per second is 3. But if you look carefully, he has asked beats per minute. So number of beats per minute per second 3. Per minute there are 60 seconds. So 3 into 60. 180 beats per minute is the answer for the problem. So that's a simple problem that we can solve basing on concept of beats. Now let us proceed to the other problem. That's other problem that we have. It is given that this is also a CBSE AIPMT question. What is given here is, again, equation of two progressive waves are given for you, y1 and y2 displacements. If amplitude and time period of resultant waves are same as both the waves, then what is the difference, phase difference between them? Phi1 minus phi2 equal to how much is the question, right? So it was given that y1 equal to a sine omega t plus phi1, y2 equal to a sine omega t plus phi2, right? Then when they are combined together, equations of two progressive waves, if you want phi1 minus phi2, I have to add both of them. Y equal to y1 plus phi2, that is a is common, sin omega t plus phi1 plus sin omega t plus phi2. This is like sin c plus sin d formula. We know sin a plus b, and this is like c omega t plus phi1. Omega t plus phi2 equal to is c sin d. So I can write sin c plus sin d is 2 sin c plus d by 2, and thus c minus d by 2. That's the formula. Let's apply that formula. So y resultant equal to a is common. Sin c plus sin d is 2 sin c plus d by 2. C is omega t plus phi 1. D is omega t plus phi 2 by 2. Cos c minus d by 2, that is omega t plus phi 1 minus omega t minus phi 2. That is a 2 sin omega t, and omega t is 2 omega t phi 1 plus phi 2 by 2, and then cos omega t cancels, phi 1 minus phi 2 by 2. So if I have to rewrite it like an equation that represents the oscillatory motion. I have to write it as 2a cos phi 1 minus phi 2 by 2. That's all becomes the amplitude of the equation. Whatever is remaining, sine 2 omega t plus phi 2 by 2 is the equation. So this part, the first part of that, is the amplitude of the equation. And it is given that amplitude is, if the amplitude and time period of the resultant wave is same as that of both waves. So I have calculated the resultant amplitude. This resultant amplitude must be equal to the amplitude of individual waves A and A. So let us take that into consideration and go ahead and write. So A resultant is, what we have derived is 2A cos phi 1 minus phi 2 by 2. That was given as A. So A and A will cancel. Cos phi 1 minus phi 2 by 2 equal to 1 by 2. That means phi 1 minus phi 2 by 2 equal to cos inverse of 1 by 2. Cos 1 by 2, cos is 1 by 2 for 60 degree. That means pi by 3. Phi 1 minus phi 2 by 2 equal to phi by 3. That implies phi 1 minus phi 2 equal to 2 pi by 3. So the phase difference phi 1 minus phi 2, that what he want to calculate, is 2 pi by 3. So it is purely mathematical, and you need to know these basic formulas to solve this kind of problems. That's it. Thank you for watching.